In the last video, we talked about how to turn on the different channels of an RGB LED using either 2 channels at a time or all 3 channels to color mix, to bring all the color together and produce colors that are not available in the LEDs on the left on our screen. So what does that look like in real life? If I bring up an RGB color selector, and I just use the one on Google, if I move the color around on my screen, I can see that these RGB values here change. So if I go up into the top brighter or the top corner here, which is a brighter lime green, I get a red value of 117, green of 252, and blue of 93. But if I switch to another color, let's say this really bright cyan color, you can see that the values have changed drastically. And this color is mainly a mix of green and blue with very little red. And as I shift down the color spectrum to this darker orange color, I can see that it's primarily red to make that orange, a little bit of green, and very little blue. Okay, so I'm going to go ahead and use this orange color, I think. This is the color I want to mimic in my circuit. So let's go back into the circuit and hit stop simulation. And we talked about the idea at the start of this lesson, analog versus digital. Analog being a continuous set of data from 0 to 256, and digital just simply being on and off. So if we want to be able to input numbers like this into a function, we can't use our digital write command. And that's where analog write comes in. Okay, so we have digital write here, and we were passing in a value of red, green, and blue. And those values of red, green, and blue, red, blue, and green were passed in as highs and lows. So we want to be able to do this again, but we want to do it with something like a number. So we might say something like this, light, LED, and I'm going to put a big A at the end to represent analog, and I want to pass in those numbers here. So I want to pass in 245, 113, 42. So 245, 113, and 42. And I used periods by mistake. Sorry, those should be commas. And you'll notice that they've highlighted, but if I try to hit start, it's going to say there's an error on line 19, and it says light LED A was not declared in the scope. So I'm going to hit into my code and realize that when I look this up in my dictionary or on my screen, I don't see it declared anywhere. So I have to actually make the function. It cannot simply reuse this piece. So just like last time, go void light LED A, and we're going to pass in some variables. We're going to use a curly brace to open our code statement and a curly brace to close it. And that's just the general syntax to get out of the way right off the start. That way we don't forget it later. We're going to be trying to pass in 3 different variables. So we might want to declare those as integers, and we'll call it int red, int blue, and then int green. Okay, very similar structure to the light LED command, but rather than using bools or booleans, we're going to use ints for integer, so a whole number. And that's going to allow us to pass in these numbers of 245, 113, and 42. Now, I mentioned earlier we can't use the digital write, but there is a command called analog write. So if I take analog write like that, and I pass in the pin, so pin 13, and I pass in red, that would be sufficient enough to light up the red channel, because that's what pin 13 is, and light it up in a way that the red gets replaced with the first number or first argument that the function uses. So if I repeat this and I copy that and I paste it down a few times and I switch the pin numbers to 12 and 11, I switch the red to blue, I switch this one to green, well, that'll allow me to turn on these 3 pins at that value. I could then allow the delay statement to run for a second. So we'll give it a delay of a second. Notice how I'm copying and pasting to avoid some typos. And then I'm going to copy these 3 lines again, just like last time. Oops, sorry, Windows. I'm going to copy those 3 lines. I'm going to paste them after the delay and then copy a second delay, just so that it actually has time to turn everything off. So rather than saying write them to red, blue, and green, I'm going to write the values to 0, which is effectively off. I'm going to turn those pins off completely. That should work. So let's give it a start and let's see what happens. So we can see that our code passes, but then we get down here and it's not working anymore because it's not being declared in scope. So it's not allowing blue to pass through. Blue has not been declared. Blue has not been declared in this scope. So let's close this and see what's happening. And oh, I can see right off the bat, I have an extra comma. So that was a mistake. So let's go ahead and try that and hit start simulation. Let's hope that doesn't happen again. And here we go. So we can see our color here turning on and off. So those are these lines of code here, and there's the orange. So let's stop simulation. And remember, we can use comments to turn lines of code off from prior examples. So especially in our loop, that's handy because we don't want to lose this code. We just don't want it to run right now. So we'll hit start simulation, and we can see that the red and the green are turning on, and it's producing a dim orange. That's not a color we had in the past. So that's pretty cool. It's not on 100% accurate way to do this, but it's enough to get it working for the purposes of our demonstration here. We would probably want to actually, if we were using analog write a lot, we'd probably want to use the analog pins. And then there's some other stuff going on behind the scenes here, which we're not going to get into today. But in general, if you wanted to, you could switch these pins to analog pins just to ensure that this works 100% of the time correctly. So that's how we can color mix. So if you want a different color, you can copy that and replace it with new colors. Thanks.